Okay, so here's a couple derivatives that you're going to have to know for today's lesson. So I'm just going to teach you the derivatives, and you're going to go to work. If you have the natural log of x, then the derivative is 1 over x. You can see that proof outlined in your book. The derivative of log base a of x is equal to 1 over natural log of a times x. Maybe I should rewrite that as 1 over x natural log of a. You don't take the natural log of a and x. The derivative of a to the x is equal to a to the x times the natural log of a. Oh, I'll show you. Don't worry. What? Oh. Ina. All right, very nice. This is 7.4 calculus and logarithms. So, okay, so we have y equals 3 times the natural logarithm of x squared. And what I need to do is I need to find the derivative of that. Okay. Chain rule, very good. No need for the product because I simply have a constant out front. So I'm going to have y prime is equal to, and we'll set up the chain rule. Do you see what the outside function is? 3 natural log of u. What's the inside part? X squared. So, according to the notes we just took, what is the derivative of 3 natural log of u? 3 over u. Yep. Yeah, we're doing the chain rule. What's the derivative of x squared? 2x. So what we can do now at this point is we can multiply them together. So y prime is going to be 3 over, what is u? X squared times 2x over 1. So you get y prime is equal to 6 over x. That is the derivative. Yeah, it did. How about you try one on your own? There you go. Try that one on your own. Go. Any questions? Yep. Oh, sure. Good question. Rebecca's question, what are we doing by finding this? So if I go to my calculator and I type in if I type in 4 natural log of x to the third plus 1 and I graph that, you can see it has a very interesting shape, right? What this is, as I found the derivative, I've simply found the rate of change at any given point. So if you want to know the slope of that function at 2, as you look at the graph, at 2, is the slope going to be positive or negative? Positive, and it looks like it's fairly steep. If you would plug 2 in, again, to your derivative right here, you would come up with exactly what that slope is. So remember that we started out calculus by defining that as the limit as h approaches 0 of f of x plus h minus f of x all over h, which you guys all just got done doing on your assignment, right? You guys just had a project like that. Well, what we're doing now is we're going through a lot of other ways in which you can find derivatives. And logarithms are a very, very effective way of finding derivatives. In fact, you can, yeah, there's a lot of application we won't even get to within our book right now. But very effective way to maneuver forward, especially within calculus 2. So let's try a different one. Yes. I don't know. On the scale of things to be concerned about, that's like number 4,000. I don't know. Okay, let's try another example. Yep. No, not necessarily, no. My goal is that we could, we'll see where we get, but that, we only have, after you practice this, we would just have really one more day, maybe 2 days of using L'Hopital's rule. Really, we have to see where we get there. We're either going to have one test or one test and a short quiz by the end of the year. So we just have to see where we get. So, yep. Yeah, I will make sure that you have all of the derivatives of natural logarithms and stuff that you need. Yep. So if we have example 3 here, well, this is a little bit different scenario here, okay? The first one's an easy derivative to find, right? What's the derivative of 4x squared? Yeah, so this derivative, y prime is equal to 8x minus, now in order to find the derivative of 5 to the 2x minus 3, what do I have to use? Right, exactly. So what Kyle sees is that I'm going to have to back up and use this derivative right here. He sees that I have an exponential function, and the derivative of an exponential function is going to be that function times the natural logarithm of a. So let's set it up using the chain rule and find that derivative. Okay, so we have 5. I'm going to write this down. 5 to the 2x minus 3. What is the outside portion of this function? 5 to the u. And the inside is 2x minus 3. What is the derivative of 5 to the u? Very good. 5 to the u, and then we attach on a natural logarithm of 5. What is the derivative of 2x minus 3? 2. So when you multiply those together, we get 2 times 5 to the 2x minus 3 times no, I mean, other than your calculator pressing a button. Natural log of 5 means this. Okay, what is the base of the natural log? E. So e to what power is equal to 5? And e is a number 2.718. So, the question is what power is that going to be? Is it going to be 2? Is it going to be 3? Is it going to be 1? Obviously it's a decimal, but That's what a logarithm solves for. So that's my derivative. Any questions? Okay. This is my final answer. Okay. Yep. You can't multiply 2 times 5 because this is 2 to the 1. This is 5 to the 2x minus 3. They're not common bases, so you can't do anything with them. What's that, Kel? Okay. All right, so here we go. You try this one on your own. See if you can find the derivative of that. That would require, very good, as Greta says, the product rule. I'll let you guys go to work there. Okay, so let's talk this one through. Everybody should be able to get this first part pretty quickly. We have 2x times 4 to the sine of x. Guys, I really don't want to compete for attention today. I'm not going to. I'll just, okay. I don't want to compete for attention here. Okay. So I've got 2 to the x. I've got 4 to the sine of x. Everybody should be able to get this far. So this is just a basic, basic setup of the product rule. Now, did everybody get this? Okay, so I set that up using the chain rule, which I've set up right over here. So I end up with cosine of x times 4 to the sine of x, natural logarithm of 4. And that will tell me the slope of the curve at any given point. Yes, Derek? No? I have no idea what that looks like. I have no idea. Kelly? That's the final answer. Ben asked if I could give a quick sketch. I have no idea what that looks like. I really don't know at all. Yes, yeah, go ahead, plug it in, see what it looks like. Have a good time. I'm not going to do that right now, but... Okay, let's try a slightly different type of problem. So we've got y equals 4 times the 6th root of the natural log of x. What to do, what to do. Sure, we could do that. That'd be fine. Very good. You're going to set up the chain rule, and what you're going to do is you're going to say 4u to the 1/6 and natural log of x. What's the derivative of 4u to the 1/6? So 4 times 1/6 is going to be 2/3. U to the 5/6 in the denominator as we subtract 1. Yeah? Okay, what's the derivative of natural log of x? 1 over x. And now we're going to multiply those together. So I have 2 over 3 times the natural log of x to the 5/6 power times x. Sure. So you would probably see it more commonly rewritten as Devin said, 2 over 3x times the natural log of x to the 5/6 power. Very good. What do you guys think? You got that? Yeah, dog? All right. No, we've got then the antiderivatives, which aren't very difficult at all, but we should really write them down. So you could add these to the formulas that you wrote before. And we say it's absolute value because you can't take the natural logarithm of negative numbers. And so if you take the antiderivative of 1 over x dx, you get natural log of x plus c. Now, the reason why I bring this up is this should really kind of fill the gap for you guys. And the reason why I say it should fill the gap is let's look at kind of the issue at hand here. You see 1 over x, if you were to try to manually find the antiderivative, 1 over x is the same thing as x to the negative 1. Correct? Everybody okay there? So if we use our power formula, we increase the exponent by 1, and we divide by the new exponent. So what you would say, that would be x to the negative 1 plus 1 divided by your new exponent, which is negative 1 plus 1, plus c. Well, that is x to the 0 over 0. And we know that when you divide by 0, you get an undefined result. And so, we can't use the normal power rule in order to evaluate the antiderivative of x to the negative 1. But what we can do is we can use it as natural log of x. If you'd like to see a proof, it's very well laid out in your book. It's pretty interesting to see how it works out. But this does now fill the gap for us, so we can really find the antiderivative of any type of power like that. So let's write down the last one, the last formula that we need, and then we can try a couple practice problems like this. If you have an exponential function, remember that before we had the antiderivative of e to the x was simply e to the x. Well, now we have the antiderivative of a to the x is a to the x over the natural log of a. And if you inserted e for a, you would end up with the same result because the natural logarithm of a is, in fact, 1. So let's try an example like this. So we're on example 6. Let's take the antiderivative of 1 over 2 minus 8x dx. So this is an antiderivative that prior to this point you have not been able to find. And once again, as you've been finding antiderivatives and you've been engaging through calculus, you haven't realized some of your limitations. And part of calculus, too, is getting rid of all of those limitations that you have. This is one of the small steps in that direction. Okay? Now, I'm going to use substitution here. I'm going to say, remember, I'm doing so it's kind of the opposite of the chain rule. I'm going to say u is equal to what? 2 minus 8x. Very good. And I'm going to say that du is equal to negative 8 dx. Do you have a negative 8 up here? No, so I'm going to divide both sides by negative 8. And I get negative 1/8 du is equal to dx. So as we glance at our original problem, we can see that the dx is replaced by negative 1/8 du. And we see that the 2 minus 8x is replaced by u. And so now that I made that substitution, I can rewrite the integral as follows. Negative 1 over 8 times the integral of 1 over u du. Well, that's pretty simple, isn't it? What's the antiderivative of 1 over u? We're gonna make sure it's positive by saying absolute value. That's kind of one of the stipulations. Times the natural logarithm of u plus c. And now I can nope. Figure it out. You can do it. If you see an n, it's going to be preceded by an l. How's that? There you go. Okay, so negative 1 over 8 natural log of absolute value of 2 minus 8x. Let's see. There you go. That's the answer. Okay, let's pause there. I'm going to give you guys some time tomorrow to work on this in class. I want to make sure you have a really solid understanding of logarithms, their derivatives, and their integrals. You could start a little bit today if you want. I know that Megan didn't get a book on Friday. Did anybody else not get a book on Friday? Jacob and Ben and Charlie? Wow, 5. Okay, I'm going to have to find some books because I don't think we have enough. So there's your assignment. You have probably 8 minutes if you want to get a few problems done. Nice job on your posters. They look great.